Hey guys, Ms. Gosling here. In this video, we're going to talk about the cosmological principle. By the end of the video, you'll be able to describe the cosmological principle and its role in models of the universe. So let's go ahead and get started. So our understanding here is the cosmological principle, and our application and skills. We have one, and that is describing the cosmological principle and its role in models of the universe. Thankfully for you, this is qualitative, not quantitative. So you're mostly just learning some definitions. So there are two key tenets of the cosmological principle. First, that the universe is homogeneous, and second, that the universe is isotropic. So let's go ahead and discuss what those two things mean. So a homogeneous universe is a universe where everything in the universe looks the same. Now, this does not mean that that every single part of the universe has the exact same structure. So like we're not in a big uniform sea of particles. Instead, what this means is that the same structures, so let's think galaxies, planets, stars, all that fun stuff, can be found anywhere in the universe. So if I took a picture of one portion of the universe, as I did here on the right of my screen, and then I took a picture of a different part of the night sky, I should see that those pictures look relatively similar. The same sorts of things are found in both. And that is the case with our universe. If I take pictures of different chunks of the universe, I see galaxies, I see stars, I see planets, I see black holes, I see all those things. Thus, our universe is homogeneous. The other quality of our universe that's important is that it is isotropic. And what this means is that our universe has a consistent structure. So not only can the same things be found throughout the universe also doesn't have a designated edge or a designated center. Now, you might wonder, okay, we've talked about how the universe is finite, right? So the universe doesn't go on forever. It's got to have an edge somewhere. So how is it possible for the universe to be both isotropic and finite? Doesn't something isotropic need to be infinite? And for that, what I'm going to ask you to do is imagine you are an ant living on the edge of a balloon. So here you are, head, thorax, and abdomen, 6 wonderful legs, so fun. And this universe, this balloon, has finite edges. It has a finite volume. But it doesn't have, from your perspective as someone stuck on the edge of this balloon, someone who can't go into the middle of the balloon, it doesn't have an edge and it doesn't have a center. Instead, if I walk around the balloon, around the universe, I'll eventually end up back where I started. When I say that the universe is isotropic, this is what I mean. That it's not that the universe is infinite, it's that if I start walking around the universe and I am immortal, so I'm able to walk all the way back to where I started, rather than getting to the edge of the universe and kind of, looking off over some sort of waterfall where things fall off, I'm eventually going to just hang back around and end up back where I started. So think of the universe instead as something that is finite, but it's finite in a fourth dimension, a dimension that we can't really experience. I know this can be a little bit difficult to wrap your head around, but it's a very key component to understanding the nature of our universe. So, takeaways, super straightforward. First, the universe is homogeneous. Same stuff found everywhere. Second, the universe is isotropic. It is finite, but it doesn't have a designated edge and it doesn't have a designated center. Every piece of the universe is created equal. So there you go. Those are some keywords that we're going to be using to talk about our universe and some of the key concepts to understanding the nature of our universe and the nature of the things that we are able to observe around us. So best of luck and happy learning.